This video is for page 6, and it is example 3 about the summer job. Sorry, I can move some stuff out of the way here. It says Alex spent the summer helping out at his family's business. He was hoping to earn enough money to buy a new $220 gaming system by the end of the summer. Halfway through the summer, after working for 4 weeks, he had earned $112. Alex wonders, if I continue to work and earn money at this rate, will I have enough money to buy the gaming system by the end of the summer? So to determine if he would earn enough money, he decided to make a table. He entered his total money earned at the end of week 1 and his total money earned at the end of week 4. Just get my word problem breakdown in here. And I'm looking for a question. It says, will I have enough money to buy the gaming system by the end of the summer? So I see a table here. The table has the weeks at the top and the total earnings. And like it said, he had entered his total money at the end of week 1 was $28, and the end of week 4 was $112. And it's really important that he's going to continue to earn the money at this rate, which means the amount that he earns per week is going to stay the same throughout the summer. He's not going to have like a week where he earns like hardly anything and then a week where he earns a ton. It stays at a constant rate. So looking at part A, it says work with a partner, which obviously you're not going to fill in the chart and answer Alex's question. So taking a look here, week 0, he wouldn't have earned any money, so that'd be 0. In 1 week, he earned $28. So if he's working at the same rate, in 2 weeks, that would be $28 a week, would be 28 times 2, which gives him 56. For 3 weeks, it'd be 3 times the $28 a week, which would be 84. And then 4 times 28 is already filled in for you, the 112. 5 times 28 would be 140. And the 6 times 28, whoops, I don't know what that was. 6 times 28 is $168. 7 times 28 would be $196. Excuse me. And 8 times 28 is $224. Now, we had class discussion about how kids were kind of tempted to just add $28 each week. That works out for this particular table. You want to be really cautious about that because some tables they might skip around. So they may not follow this pattern of, adding 1 week on. So while it will work on this table to add 28 each time, it's better to be looking for that relationship between the weeks and the earnings. So answering Alex's question, he says, would you have enough money to buy the gaming system at the end of the summer? At the end of the summer, he has $224, and he needed $220. So we would say, yes, Alex would have enough money at the end of the summer. Moving on to part B, it says, are Alex's total earnings proportional to the number of weeks he worked? So that's a question. And how do you know? So total earnings proportional to number of weeks. So it's going to be the money to the weeks. And as we've been working through these, whenever we're determining whether it's proportional, you have 2 choices. You can use your ratios, which would be taking the money, 28, putting it over the weeks, which is 1, figuring out what that equals, and continuing that all the way through the table. In this particular table, I'm just going to put dot, dot, dot. In this particular table, though, because we really have already used that fact that it's the weeks times 28, using that common multiplier would be a more efficient way. So we know it's always the weeks times 28 weeks times 28, weeks times 28, and so on. Sorry, really noisy car going by. So we would say yes, because there's a common multiplier of 28. And we showed that with our success criteria right there. Of course, if you'd used the ratios, you could have said that there was a common ratio, and that would work as well. And that's the end of the video.